This is the second part of the solutions for the study guide, starting at number 10, and it asks us to dilate the figure by a scale factor of 1/2, and then also sketch the image of the coordinates plane below and list the ordered pairs. So we're going to go ahead and list the ordered pairs here. I'm going to start with this one being A, and so I'm going to call it A and then just name the point. So it looks like it goes over 1, 2, 3, 4 points and then up 2. So -4, comma 2. And then B is, I'm going to go up in this direction here, so I'll call this one B. So this looks like it's up 1, 2, 3, 4, 5 points. So B is 0, comma 5. And then C is down here, and this is 1, 2, 3, 4 spaces to the right and 2 spaces up, so 4, comma 2. D is right here, and that would be 2 spaces to the right and 2 spaces up, so 2, comma 2. And then I'm going to go down, straight down from D to E, and that's this one here. So it's 2 to the right and 4 down, so 2, -4. And then a point F is going to be right over here, so it's 2 to the left and 4 down, so -2, -4. And the last point, G, brings me right back up to this point right here to finish off the arrow, and that's 2 to the left and 2 up, so -2, comma 2. So once I've got those, the scale factor is 1/2, so I'm halving each of these numbers. And so again, what that's going to look like is this. I'm going to take these values here, and I'm going to take half of each of the x values, and I'm going to take half of each of those y values. And that's going to give me these new values, which will give me the new image. And since I'm changing the image, I'm going to say A prime instead of just A. So it basically corresponds to point A. It's just being each of the values to make up A are being halved. So -4 times by 1/2 gives me -2, and half of 2 gives me 1. So again, all I'm doing is -4 times by 1/2 gives me -2, and -4 times by 2, which is the same thing as 2 over 1. Let's see here. So let me go ahead and fix that. It should be 1/2 instead of multiplying by 2. So -4, oops, that was the first point, so let's go ahead and fix that again. So I did -4 times 1/2, now I got to take 2 and take 1/2 of that, and that's where I'm getting 1 from. So let's take a look at B prime. So B prime, just taking half of these numbers. Half of 0 is 0, half of 5 gives me a fraction, or a mixed number, 2.5. So C prime, half of 4 is 2, half of 2 is 1. And then D prime, half of 2 is 1, and half of 2 again is 1 as well. And then I go over here, half of E prime is going to end up being 1 and -2. So half of 2 is 1, half of -4 is -2. And I'm on to F prime, and that's going to end up being -1, -2. So half of each of these numbers. And then G prime, half of -2 is -1, half of 2 is +1. So once I go ahead and do that, and then I just plot these points. So -2 to 2 to the left, so this is 1, 2, and then I go up 1 space, and then over 0 up 2.5 spaces, so it's going to be right in the middle between 2 and 3, and then over 2 up 1, and then down, let's see here, and then this next one, 1, 1, so I have to go over a little bit there. And then over 1 space to the right, up 1, and then I go over 1 down 2, so it's going to be right there, and then I go over 1 to the left down 2, so over 1 to the left down 2, and then I go 1 to the left and then 1 up, so 1 to the left, 1 up puts me right there. And then once I have those points, I can connect them with lines, and I've got my shape. So there it is, the same shape, similar shape, but just half the size of the original one. And so let's take a look at the next type of problem that we'll end up seeing, and it would be these. And so number 11 says that it wants us to talk about how Ed stands next to a monument in Chicago, and he casts a shadow that's 18 feet long. So here's Ed's shadow, it's 18 feet, and this is Ed. Don't know how tall Ed is yet. The shadow of the monument is 204 feet, so much longer shadow, and then the monument's going to be taller as well, but I'm running out of room, so I'll just stop it there. So 204 feet. And then it says, if Ed is 6 feet tall, okay, we go back to this original drawing, and put a 6 feet right there. They want to know how tall is the monument. Don't know, so that's what we're going to put our x next to. And so notice this is a right angle right here, and so we can make a triangle out of it. And so if I can make a triangle, and I'll go ahead and sketch that in real quick. This triangle right here, and then right here. So what these are similar triangles if they're corresponding. And they are corresponding because the sides are corresponding because they're Ed and is standing next to this monument. He's casting a shadow, and the monument's casting a shadow, and those are going to be corresponding, and they're going to be similar triangles as well. So what we're going to end up doing is we're going to set up a ratio, and you can set up a number of different ways, but I'm going to do it this way. I'm going to do 6 to 18, and then since I started with the 6, that's the height. That means I need to start with the height of the monument. So I'm going to do x is to 204. So basically what I'm doing is the height to the shadow, height to the shadow. And when I do this, as long as there's lots of different ways you can set this up, but as long as 18 and x are diagonal from each other, it will work out. And so let's go ahead and solve this. And so what I'm going to do is I'm going to first reduce this fraction. I'm going to take out a 6, make the problem a whole lot easier. So this becomes a 3 and this becomes a 1. Then I'll multiply diagonally, so 3 times x, so 3x. And then 1 times 204, so it gives me 204. And then I just divide by 3. And so I see 3 goes into 20, goes into 26 times, 8 left over, or making 18 with 2 left over. And 3 goes into 24, we have 8 times. And so that gives me that evenly. And so 68 feet. So we'll say the monument is 68 feet tall. Well, let's take a look at the next problem, and it talks about how while playing tennis, Matt is 12 meters from the net. So here's the net right here. That's what it says. And so 12 meters from the net. And the net is 9/10 meters high. So I'm going to put a 0.9 right here. And then he needs to hit the ball so it just clears the net. So just cleared the net, but lands 6 meters beyond the base of the net. So 6 meters over. And so which triangles are similar, it says, and how do you know? So the triangles that are similar are this one right here and this bigger one. So let's name them. Triangle ABC is going to end up being similar to triangle, and then we have ADE. So ADE. So that's the bigger triangle. Now how do I know? So let me go ahead and do it this way. We'll go ahead and say that because and continue on here, because they share an angle, and actually I'll even say, we'll say an angle at point A. And so right in this location, right over here, they share this angle where CAB is the same as EAD. So they share that angle. That's one angle that they share. And then we'll say, and both have a 90-degree angle. And that's given by this symbol right here. So we see that CBA is the same as EDA. So they both have that. Since they both have two sets of angles that are the same, then we can go ahead and say that these two triangles are similar. So here's the sentence we can go ahead and use. We can say, since the two triangles have angles that are the same, and specifically we'll say, since two triangles have, we'll go ahead and add in there, since two triangles have two angles that are the same, the third angle must be the same as well. And so the saying that we end up using for that is, this is the angle-angle postulate. And so that allows us to say, once we find two angles being the same in two triangles, then I would know that the two triangles are similar because all angles would be the same. And that's what makes a triangle similar, is if all angles are the same. Well, check out the next tutorial for the last few problems.